Good afternoon and good morning to you all. Welcome to this session that will focus on Earth observation technology and how this has helped for SDG 11 and New Urban Agenda monitoring. My names are Robert Ndugwa. I'm the current chief for the data and analytics section here at UN Habitat. A good way to build the context for this session is to understand that urbanization is not only a demographic or spatial phenomenon, but a force which, if steered and deployed correctly, can help the world overcome some of its major global challenges, such as poverty, environmental degradation, climate change, etc. However, what we see is that a higher proportion of cities ultimately formulate policies and action plans without clear evidence. It's estimated that as high as 65% of local authorities do not know how and why the city is growing, and who or what is behind this sort of growth. Despite considerable progress in many years, still whole groups of people and places are not being counted, and important aspects of people's lives and city conditions are not properly accounted for. For people, this can lead to the denial of basic rights, and for the city, the likelihood that they do not take full advantage of the transformative potential of urbanizations. Obviously, despite the credible value of Earth observations data as a source for monitoring progress in our cities and communities as laid out under SDG 11, many cities and countries still lag behind in terms of the capacity to leverage the value of Earth observations. Very often, we've made the message that timely data, technology, as well as packaging that into knowledge are fundamental aspects for us to understand urbanization gaps and needs, as well as to help us recognize the need to critically link data to evidence-based policy formulation and the development of action plans. What we see under Goal 11 is that nearly 7 out of the 10 targets require some sort of Earth observations technologies to monitor progress. However, for this to succeed, we need strong partnerships and collaborations at all levels. We need to build the capacities of the national and subnational entities that are using this sort of technologies to collect and compile data. And at the same time, we need to coordinate amongst ourselves around these innovative approaches to support urban data collection efforts amongst all partners. As we'll hear later today, the Earth Observation Toolkit is one aspect that is directly addressing some of these challenges that we've identified. Thank you.
Hi, my name is Monika Kuffer from ITC University of Twente. I will talk about the potential of Earth observation for the urban SDG and the new urban agenda, in particular highlighting the role of Earth observation to fill data gaps. Taking the example of the SDG 11.1 indicator on slums, informal settlements, inadequate housing, we see that data are typically reported at national level, however, are not available at the local scale. Existing data are highly uncertain and have large data gaps. Taking the example of India, we see a decline of the slum population, while also an increase of the urban population. However, such data are very uncertain. Taking the example of the city of Bangalore in India, where we had worked on, we see that a large part of the slums which existed and which we found using Earth observation systems and confirmed from ground survey are not officially recognized and reported. In these cities, large parts of the unreported slums are temporary slums which are very dynamic across the city. The role of Earth observation to support urban policies. We see that Earth observation has a large potential to fill this data gap, having the capability of showing temporal dynamics, as an example. However, what is still on development and needs to develop and to promote the broader use of Earth observation system is the availability of open source in terms of data, in terms of models. That's something which we are presently working on with a focus of sub-Saharan African cities. In this context, we also fill another existing data gap, which has to do with the understanding and assessment of local user needs and data requirement, ranging from a global to a national and to a local level, where we see at the local level communities, NGOs, and local authorities being key to understand local data requirements. The challenges and innovation of Earth observation has to do that we need to make data better accessible, in particular to local user groups, being able to access models, but also providing local user support. Data need to be available at scale, meaning that data need to be available at a scale users are requiring them, for example, at city level, at the level of urban regions. Data need to be transferable and methods need to be developed in a way that they are transferable across cities, across countries, across continents. We need to better understand via use cases the user requirements and promote within user groups the use of Earth observation-based data. Taking the example of the understanding of, for example, of environmental conditions, like the example of local urban heat islands, which are particularly impact poor urban communities. Understanding the potential of Earth observation has to do and to start at a local level with an identification of existing data gaps. This can be data gaps on the urban morphology, on land cover, on land use, and environmental condition. Showing here the example of the city of Kampala in Uganda, we see a stark decline of open spaces, in particular of green open spaces within the city. However, data are often available, but local users are not aware of the availability of data. There are a large number of data repositories which could provide urban data needs. As an example, an emergent data repository on information on deprived urban areas, slums, informal settlements, which is under development. Some final thoughts on the potential of Earth observation to support the urban SDG and new urban agenda. First of all, we need to better understand user needs by developing use cases, developing a platform of exchange of experiences between users. We need to ease data access, data sharing, and the co-creation of knowledge. On the development of Earth observation methods, they need to be at scale of the users and user requirements. We need to develop transferable methods, need to provide access to data, not only to image data, but also to ground in situ data. On a practical use case level, we need to account and provide guidance and document data accuracy, providing timely data, but also acknowledging and taking account of data privacy and ethics. In this way, we can support an optimal use of Earth observation data and systems at local level for better supporting the use of Earth observation data for local policy making. Thanks for your attention. Goodbye.
The Human Planet Initiative is committed to develop a new generation of measurements that provide a more integrated understanding of the human presence on the planet Earth. The goal is to generate global-scale data and knowledge to advance our understanding of societal processes and their impact on Earth systems, and to generate useful indicators to inform policy. An immediate objective of the Human Planet Initiative is to support the post-2015 international frameworks, the 2030 Agenda for Sustainable Development, the Sendai Framework for Disaster Risk Reduction, the Paris Agreement, and the new Urban Agenda. The following example for the city of Bangkok in Thailand will illustrate how data produced by the Geo-Human Planet initiatives allows generating actionable and goal-driven metrics. NASA's Socioeconomic Data and Application Center, CDAC, at CIESIN, which is a co-lead of the Human Planet Initiative, is collecting census data and produces the gridded population of the world. GPW provides a spatially disaggregated population layer that is compatible with datasets from social, economic, and earth science disciplines, as well as remote sensing. The map shows the population density for the administrative units of Bangkok and its surrounding. Although the city center is clearly visible with the highest population densities, the information remains quite coarse, especially in the larger units of the hinterland. To improve this, the Joint Research Center of the European Commission, the second co-lead of the initiative, has developed the Global Human Settlement Layer that maps automatically built-up areas from free and open satellite imagery such as Landsat or Sentinel-2. The high resolution of the satellite imagery allow a much finer delineation of the settlement extent. If we combine the two datasets and distribute the population report by the census into the built-up areas mapped by the satellite data, we obtain a high-resolution population density map. Individual settlements in the surroundings of Bangkok become visible, and the variations in population density in the city center become much more nuanced. With the population density maps, it is possible to delineate cities, urban and rural areas based on density thresholds. This new settlement classification, the degree of urbanization, was adopted in March 2020 by the UN Statistical Commission for International Comparison, including the SDG monitoring. With these three ingredients, global built-up area grids, population density grids, and the delineation of settlements, it is possible to calculate the land use efficiency for any settlement in the world. The map provides the results for the period 2000-2015 for all cities above 50,000 inhabitants and shows interesting regional differences. The tools to calculate the indicator are available from the GHSL website. With a network of more than 200 partners from science and policy, the initiative has an impact in modeling exposure and vulnerability to natural hazards, conflict, and environmental change, measuring the impact of human activities on life-supporting ecosystems, and estimating human and societal demand for natural and other resources. If you are interested to join the initiative, feel free to contact us.
Hello, my name is Dilek Fraisl. I'm a researcher at the International Institute for Applied Systems Analysis, and I will talk about citizen science today and how it could complement Earth observation approaches in addition to traditional sources of data as part of our Earth Observation Toolkit for SDG 11 partnership. But first, I would like to thank the moderators for inviting me to speak in this session. First of all, what is citizen science? There is no agreed definition of the term, but our approach to it is an inclusive one. So we define citizen science broadly as the voluntary public participation in scientific research and knowledge production. Some relevant terms would be community-based monitoring, participatory research, citizen-generated data, and crowdsourcing. We recently published a paper in the journal Sustainability Science on the contributions of citizen science data to SDG monitoring. Our findings show that the greatest potential for citizen science data for SDGs would be in SDG 11 and SDG 15, which is directly related to our Earth Observation Toolkit efforts. One example I would like to give in terms of SDG 11 is the City Oasis project or app for the indicator 11.7.1. This indicator is about the built-up area of cities that is open space for public use. Measuring how much public space a city has doesn't give an idea on whether people actually benefit from them. This is where citizen science approaches could come in to complement Earth observation data, as it could help collect additional information on the perception of residents about these open public spaces. CityOasis aims to improve the database of open urban spaces and their use in Vienna. Participants could use the CityOasis app to add open public spaces, upload photos, rate these spaces, and answer questions on how safe they find them, and answer other questions such as if they are noisy or clean, and others. The project is a partnership between IIASA and the City of Vienna. The important thing is that City of Vienna plans to use the results of the project to improve its database on open public spaces and identify people's perceptions on them. Another example where citizen science and Earth observation approaches could complement each other is the SDG indicator 11.5.2. This indicator is about the economic loss and damage attributed to disasters. Citizen science initiatives such as PicturePile could inform this indicator. PicturePile is designed to be a generic and flexible tool for ingesting imagery that can be rapidly classified by volunteers. These images can be high-resolution satellite images, images from drones, or geotagged photographs. The app asks volunteers whether they see any damaged building in the photos shown. Developed by IIASA, PicturePile has also been used to collect data on slum mapping or poverty assessment, among other areas and indicators. Other indicators such as the urban population living in slums and many others under SDG 11 or other SDGs could benefit from the combined use of Earth observation and citizen science approaches, and these were only just a few examples of them. In terms of the challenges we encountered using citizen science approaches for SDG monitoring, I can talk about the Citizen Science for SDGs Ghana project. As part of this project, led by IIASA and SDSN Trends, we are working with the Ghana Statistical Service, UNEP, Convention on Biological Diversity, and others to apply citizen science approaches for a few indicators identified by Ghana based on their data needs, such as marine litter data. We're still at the early stages of the project, but one of the issues we face is to reach out to, bring in, and coordinate with the key stakeholders. And we saw that the coordination between government agencies is particularly important in such projects. Another challenge is that the COVID. Actually, the COVID limits our data collection capacity to a great extent and delays our implementation in the specific of the indicators we're working on in Ghana. Additionally, organizing workshops and training events for data collection activities will also be difficult, but we plan to do all these online. My recommendation to countries and cities that want to improve their monitoring and implementation capacities, especially in the specific of SDG 11, is that they can have a look at the existing practices based on their data gaps and needs. Just search for what is available out there in terms of tools, data, and also examples, by which I mean the experiences from others. Of course, while considering their national and local contexts. Our Earth Observations for Sustainable Cities and Communities toolkits could be very helpful in that sense. So they can certainly have a look at the list of relevant data sets and tools we're producing, and additionally, they can check out the success stories and country and city experiences we're working on. Of course, getting in touch with our group when they need support would certainly be useful. As part of this effort, we also plan to facilitate country-to-country or city-to-city learning and organize trainings, workshops, and so on. In terms of the potential of Earth observation and citizen science approaches, I think it's clear that if we want to achieve the SDGs, we need to be able to track our progress towards them, and we need accurate and timely data for that. The funding needed to measure all the SDG indicators using only traditional data sources is a huge barrier, particularly for developing countries. So we need to utilize new sources of data, such as Earth observation and citizen science. I think this holds true when I talk about both citizen science and Earth observations approaches. One of the major lessons is that all these efforts require an enabling environment where supportive institutional, technological, financial, and policy-related actions are in place. Additionally, building key partnerships will help to ensure ownership among all the stakeholders, which is essential for the success of the project. Thank you very much for your attention, and I will be happy to answer any questions you have. Thank you.
The South African National Space Agency has been working on the integration of Earth observation data in SDG reporting in collaboration with the National Statistical Office and the Land Ministry responsible for SDG 11 reporting. During the development of 2019 countries report, SANSA participated in the National SDG Data Working Groups, which provided us with an opportunity to identify data gaps which could be filled by Earth observation data. It also gave us an opportunity to demonstrate the role of Earth observation in SDG reporting. At the end, we agreed with the stakeholders that we will focus on the computation of SDG indicator 1131, which was included on the country's report. The maps show some of the results we achieved in terms of assessing urban growth in the selected cities. Also, there's a link to a paper that was published. The development of the EO toolkit will help us strengthen our relationship with the cities who are looking at reporting some of these indicators at a city level. The toolkit will also help us communicate better in terms of the role of Earth observation in supporting other development agendas, from the integrated development plans to the national development plan, amongst others. South African metropolitan cities are acquiring aerial photography to support urban policy and evidence-based decision making. One of the acts or policies that require the use of Earth observation data is SPLUMA Act, which focuses on land use management. The cities are also starting to integrate satellite imagery in their projects, which SANSA has been making available. This includes the spot mosaic and also access to very high spatial resolution data. In terms of the problems we encountered, even though we don't see this as a problem, we see this as an opportunity. The unit responsible for the SDG data collection is not necessarily GIS unit. It's independent of the GIS unit. This provided us with an opportunity to simplify our communication and also to look at the communication strategy when we are communicating with stakeholders who are not necessarily GIS specialists. In terms of advice for countries who wish to start applying Earth observation data, there's a need for collaboration and engagements with all the stakeholders, from the national statistical offices to the cities, data providers, and also the land ministries responsible for reporting. This will ensure that everyone takes responsibility, and also that the data is used, and there's also continuous access to the required data that is necessary to support the SDG indicator computation. The potential of Earth observation goes beyond just the monitoring of the SDG indicators or newer topics or agenda. The potential also rely on using Earth observation data to support the implementation of the development solution. As you all agree that the success of any development agenda is also based on the data that is used as foundation for the development of those solutions. So it is important that when we communicate, we also highlight the need for integrating Earth observation data in planning and implementation of those development solutions. Earth observation data also provides an independent source of data for monitoring of the set targets and agenda, also at a national or city level. In terms of the experience, we learned the need for collaboration and partnership in terms of ensuring that EO is integrated in SDG reporting. And also we need to, as data providers, we need to simplify the communication when we are communicating the value of Earth observation data, especially to those who are mandated to report and also those who are mandated to implement the solution for sustainable development. Thank you for attention.
Hi everybody, I am Samira Ouadday. I am working in the Statistical Institute of Tunisia. I am going to speak about the Tunisian experience in the use of Earth observation, measuring SDG 11 indicators. First, I have to tell you that Tunisia was chosen between 4 pilot countries to collaborate with UN Habitat and the Economic Commission of Africa for the implementation of the project SDG 11, monitoring and reporting on human settlement indicators in Africa and Latin America. This project aims to support the design of monitoring tools that can improve the availability of urban data and statistics to develop results-based policies and facilitate access to them. During this project at the IIASA, we tested the tools developed during all the projects to measure the SDG 11, especially those based on GIS and Earth observations. These tools were developed by the UN Habitat experts. The pilot project permitted us at the IIASA to use Earth observation for calculating indicators 11.3.1 and 11.2.1 and 11.7.1 for 2 cities which are Monastir and Tozeur. For the indicator 11.3.1, which is the ratio of land consumption rate to population growth rate, we use Landsat and Google Earth imagery to delimit the city's boundaries and to define the built-up area for the 3 years corresponding to the last censuses. 2 workshops were conducted by the experts of UN Habitat to support us in the exploitation of the imagery and computation of the indicators. These courses helped us learning the manipulation of the Landsat imagery and the use of GIS tools for spatial analysis. Also, it was the first time that we integrate statistics and spatial data for computing indicators at IIASA, and this opportunity permitted us to recognize the benefit of Earth observation in combining other sources of data like administrative data and census data, which are used to compute 11.3.1 indicator. So for the indicator 11.2.1, which is the proportion of population that has access to public transport, we use Landsat and Google Earth imagery also to delimit the city's boundaries and to define the built-up areas. And the same thing for the 11.7.1 indicator, which is the average share of the built-up area of cities that is open space for public use. But other INS in Tunisia, other institutions use Earth observation also in their work, like the Department of Urbanization in the Habitat Ministry, which uses satellite imagery to support the creation of urban plans. Also, the ERU, the General Urban Development Agency, specializes in the rehabilitation of social council housing, uses Earth observation also data for spatial planning and observation of urban expansion, especially in the control of the informal expansion of buildings. During our pilot project in IIASA, we encountered problems related to gap in technicians specialized in Earth observation data manipulation to finish the work for the other cities in Tunisia. Just some people were trained in the manipulation of satellite imagery. Also, we have noted that quality of free Earth observation isn't always good for Tunisia, and in the other hand, the cost of good satellite imagery is high. Therefore, we use Google Earth imagery also and plan to acquire adequate satellite imagery with the next census planet in 2024. The most important challenges is the delimitation of cities, since we don't have a national definition and identification of the city's boundaries yet. For this reason, we adopt the European Union definition and apply it in our case. Also, the gap in GIS data for administrative sources like buses stations conducted us to use Google Street Map and difference the missed data manually. So, our recommendation and advices for other countries or agencies that wish to start applying Earth observation for SDG 11 can be summarized in 4 points. The first one, to study closely the experiments carried out by UN Habitat and pilot countries in measuring SDG 11 indicators by using Earth observation. This can be done with the help of UN Habitat experts. The second point is to make tests and on the basis of these tests adapt the methodologies at country context. Countries have also to adopt the methodologies developed by UN institutions and all stakeholders for unifying the definitions and concepts necessary in the measurement of SDG 11 indicators, like the city definition. The city, I'm talking here about the city boundaries, the functional urban area, the degree of urbanization, and so on, in the aim to make logical comparison of the indicator values between countries. I think also that partnership involving intergovernmental organizations, NGOs, and universities in the country will greatly contribute to the success of the application of Earth observation for SDG 11 indicators. Cartographic agencies and GIS administrative data producers can play an important role in such projects. But according our short experience in using Earth observation for SDG 11 indicators computation, I think that the satellite imagery are important nowadays, and they provide data in the delimitation of cities' boundaries and the detection of urban expansion. The satellite images can help in the analysis of the urban development in space and time. Free Earth observations are available now, and it helps a lot in providing up-to-date images and at regular temporal frequencies. This makes possible the computation of the SDG 11 indicators in most regions and of the world, of course, and at regular periods, and helps monitoring land changes. The introduction of Earth observation in the computing of SDG 11 indicators has a lot of potential also on the statistical work by adopting new methods like spatial analysis and non-traditional sources, which enhance enormously the statistical capacities. So this is our small experience in the use of Earth observation for SDG 11 indicators, and we are sure that if we arrive to overcome the problems encountered, we can help and apply all the methodologies for all Tunisian cities. Thank you very much for your attention.
Hi to everybody, it's a pleasure to me to be here. I am going to talk about the Colombian experience in the use of air observations to calculate SDG indicators. Well, first of all, I want to mention that in the National Statistics Office in Colombia, DANE, we are recognize the importance in the use of air observation data to produce statistics, especially for SDG 11 indicators. We recognize that if we use the air observation data combined with other sources of information like administrative register, census data, cadastral information, there are a big opportunities to produce statistical information and especially 11 SDG indicators. For example, thanks to the use of air observation data with other sources of information, in DANE, we can calculate indicators 11.3.1, 11.7.1, and recently we are focused in a methodology to calculate other additional indicators as 11.1.1 and 11.2.1. So definitely there are a lot of opportunities to use air observation for these indicators. Well, in this process, we have a lot of issues and challenges. For example, at the beginning, we need to improve our capacity building and also in search strategies to have infrastructure that help us to process large volume of information. To do that, to solve the situation, we are right now, we are using cloud platforms like Google Earth Engine and others that help to process this information in the cloud. And also this platform help us to have access to a set of air observation data and also have access to algorithms and scripts. Other issue was that especially in Colombia, we have some areas that has a lot of clouds, for example, in the Pacific areas. So because we use optical imagery, we have some problems to process data and have access for these areas. So for that reason, we are focused in the research to use radar imagery and other sources as other source of information. Well, which recommendation we have to other agencies and organizations that wants to use air observation data? Well, some very important is make audience, to know the work of others. So we recommend to make alliance and partnerships with academia and regional and international organizations that help to improve the capacity building and also that help to know the experience and the lessons learned from others. So it is important to know which methodology use other institutions, or also, for example, make alliance with the cartography agency. This can help to have access to high resolution imagery. So it is important to work with others to learn about the work of others. For example, review the methodologies available by UNAVITAT and investigate different international methodologies provided by other institutions help a lot. Well, we have the potential in the use of air observation, definitely a lot. The territory changed a lot, and the urban areas especially has a big dynamics. In the urban areas, there are a lot of changes, new buildings, new areas. So the satellite image, or well, the air observation image, there are a big source, a good source of information that help us to provide information updated to high resolution. So this helps a lot to have access to updated information in a very short period of time that help to monitoring changes in the territory. And this has a lot of potential, not only for SDG indicators of statistical information, but also for other aspects like risk management, planning, and other issues. So yes, there are a big potential in the use of air observation to know more about the territory and how this territory changed in the time. Well, this is our experience. We are totally, we are sure that this information has a lot of potential. We need to continue to work on that. So thank you very much for this time. Well, we are sure that there are more work in this area. Thank you very much.
Hello, I'm John Waterhouse. I'm Native American of S'Klallam, Chippewa, and Cree descent. I'm coming to you from the University of Idaho, where I'm a research scientist and Indigenous peoples scholar. I'd like to speak to you about the Indigenous peoples of the world and their place within the Sustainable Development Goals. A significant resource with regards to the SDGs is often overlooked. That resource, Indigenous knowledge and wisdom. The traditional Indigenous peoples have lived sustainably down through the millennia, being keen observers of society, the earth, and natural systems. From them, we can learn many of the steps on our path to the future. In the current era, the Indigenous community has taken steps to revitalize Indigenous wisdom. Listen to the elders, as we say, and apply it to the current environment. This has resulted in many programs, some of which are natural resources programs, native food programs, Indigenous home construction, alternative energies, providing for the homeless and needy, military veteran assistance programs, and traditional language and knowledge revitalization programs. All of these steps, though, have not been taken in isolation. Rather, some of them have been achieved by employing the latest technologies combined with Indigenous knowledge, and in collaboration with many organizations that use the very latest in Earth observation. Some of those organizations, NASA, which has assisted Southwestern American tribes with forest fire science and management. Northwestern American tribes with revitalization of eelgrass beds and kelp forests to serve as nurseries for ocean creatures. The U.S. Geological Survey, working with tribes in the United States and First Nations in Canada on the Yukon River to understand the effects of permafrost thaw. WEP Cloud, based at the University of Idaho and utilized as a watershed scale management tool. And LINK, the Living Indigenous Network of Knowledge, focuses on water quality and cultural documentation as well as environmental health. These are just a few of many programs that the Indigenous have employed right alongside their Indigenous knowledge to make a better future. To all who are listening, though, I would encourage you to engage the Indigenous populations, build a trust relationship, and bring them into the sustainable development conversation and planning at very highest levels. In closing, look into the future, the potential for success with the SDG goals through a trust collaboration of modern science and Indigenous knowledge is unlimited and will lead us to a sustainable future. if we have the courage to pursue this path. Thank you for letting me speak today, and I hope to have further conversations with you and deep discussions on this subject with the indigenous people. Thank you very much.
Hello, everyone, and welcome to our session, Tools to Enable UN Member States at national and local level to use Earth observations to help deliver Sustainable Development Goal 11 on sustainable cities and communities and the new urban agenda. This session has brought together representatives from national statistical offices, UN agencies, indigenous communities, and representatives from the Earth observations community to share experiences and perspectives on how Earth observations can and already do support sustainable urban monitoring, tracking, and implementation processes at country and city level. Our panelists have also discussed the ongoing efforts of the Group on Earth Observations and UN Habitat through consultation with countries and cities from across the world to develop a knowledge resource on Earth observation uses for urban-related topics, the Earth Observations Toolkit for Sustainable Cities and Communities. And so my name is Kavvada, and I serve as the lead for Sustainable Development Goal activities at NASA, the National Aeronautics and Space Administration, and I also serve as the Executive Secretary for the EU for SDG initiative within GEO. I will be moderating today's session with Marc Paganini, and so I will now hand it over to Marc to introduce himself and the panelists for today's session. Marc, over to you.
Thanks, Santi, and hello to everybody. I would like first, of course, to thank you and Robert for inviting me to moderate this session. My name is Marc Paganini. I'm a technical officer at the European Space Agency, working in the Science Applications and Climate Department of the IIASA Directorate of Observation Programs. And I would like, first of all, to introduce the panelists who are with us today. Unfortunately, not all panelists were able to join the debate. And I would like also to acknowledge all those who could not be with us today. If you want to know more about them, about all the panelists and the presenters, you can find the full bios on the site of the World Data Forum. So we have today a number of very good panelists, I must say. We have Thomas Kemper, who leads the Global Human Settlement Layer projects in the Disaster Risk Management Unit of the Joint Research Center from the European Commission. We have Robert Chen, the director of the Center for International Earth Science Information Network, better known as CIESIN, which is a unit of the Earth Institute of the Columbia University. We have Monika Kuffer, an assistant professor at the Faculty of Geo, Information Science and Earth Observation, better known as ITC, which is part of the University of Twente. We have Dilek Fraisl, a research scholar at the Center for Earth Observation and Citizen Science of the International Institute for Applied System and Analysis, IIASA. And we have Samira Ouadday, the head of the Regional Statistics Department in the National Statistics Office of Tunisia. And we have also Sandra Moreno, the technical director of the Geostatistical Divisions of the National Administrative Department of Statistics in Colombia, better known as being Nale. So before starting this debate, I would like to congratulate all the panelists for your inspiring presentations. You all show very well the importance of Earth observations in urban development strategies and policies. We can summarize your presentation by saying that sustainable urban development requires some evidence-based and data-driven approach, which implies an access to reliable, timely, and continuous observations everywhere in the world. You show that the integrations of these geospatial information and Earth observations with traditional statistics are becoming a fundamental requirement for countries to achieve the ambitious goals of the new urban agenda and of the sustainable development goals. But you also stress the fact that the institutional and technical challenges that countries and cities are facing need to be really addressed when we try to harness the power of Earth observation in the countries. So during this debate, we would like to discuss with you how we can enable countries and the local communities to embrace Earth observation technology in their process and systems, and how we can also enhance their capacities. So we'll ask the first question to Thomas. Thomas, you said during your presentation that one of the objectives of the GEO Human Planet Initiative and also the Global Human Settlement Footprint is to provide global scale data and knowledge to advance the understanding of societal processes inside cities. Can you better explain how this global data set can be used in a national or city context?
Yes, thank you, Marc. Well, in the past, obviously, global data, everybody thinks immediately, this is coarse data. This you can use for climate modeling, maybe to understand climate changes at a global scale, but this is useless when it comes to analysis of national situation or even at the city level. But luckily, we are experiencing now a dramatic change on the landscape. So we have a lot of free and open data that is coming up. That is, on the one hand, provided also by citizens that support initiatives like OpenStreetMap, where people are start digitizing roads and houses, etc. But also on the Earth observation side, there's a lot of improvement, where now we have free and open data at a scale that provides information also at the local level. And this is really where the GEO Human Planet Initiative tries to chip in. It tries to combine all those sources to have globally harmonized information that still provides information also at the local level, so down really to the city level.
Thanks a lot, Thomas. And I have a similar questions to Bob. Bob, you work more on the population data sets. And so can you share an examples of what the great population data sets that you are developing and that are available in every part of the world have been applied to inform urban sustainability at a national or city level?
Thanks, Marc. Yeah, there's many cases where people are starting to see the value of these kinds of population data sets and related information at the urban scale and certainly within countries. Our center has been working with an international project called the Geo-Referenced Infrastructure and Demographic Data for Development project, which is working in at least 10 countries in Africa. And they've been making a lot of progress in applying these data for a whole range of sustainability issues, including many of the large cities, but also smaller settlements. So the data is being used in vaccine campaigns, in planning water sanitation, planning access to schools, and to make sure that schools are accessible to populations around the country. So there's, I think, a lot more realization that these data can be employed at the local scale. They can be improved with local data, as well as using these global resources.
Thanks, Bob. I give it, yeah.
Yes, great. So for next, Sandra, over to you. I wanted to ask you a question. So one of the items that you mentioned in your presentation was about the need to have a platform that allows countries to investigate different international methodologies which can be applied to help inform a specific indicator, for example, and a specific SDG indicator, and to share best practices. And so I wanted to ask you what type of computing environment, in your opinion, would be needed for such an analysis and also for knowledge sharing, and how do you see the Earth Observations Toolkit for Sustainable Cities and Communities effort contributing toward this regard?
Thank you, Argy. Yes, it's important that provides to the countries and documents that explain the concepts, the methods that could be used. But also it's important to share algorithms or scripts that allows to replicate or adapt to provide information that help to reproduce these calculations. So it's important to provide documentation and scripts and algorithms. And in this context, I consider that it's important that the Air Observation Toolkit for Sustainable Cities contribute to these efforts to collect these official methods and provide these scripts with documents that help to understand how these scripts work and how these scripts could be adapted for each country depends on its needs. Thank you.
Thank you, Sandra. So the next question is for Monika. So Monika, you talked about the necessity to have open source algorithms and models in addition to open data. Can you explain why an open source framework is so important and how the Earth Observations Toolkit for Sustainable Citizen Communities can promote such open source frameworks for more effective exchange of knowledge?
Thanks for the question. Also in line what we have been discussing already, I'm working particularly on the indicator 11.1.1 on slums, informal settlements, inadequate housing. And what you see is that there is very limited data at the local level available. That's also what could be observed when we now faced the COVID-19 outbreak, that data were urgently needed at a local scale, but not available. Data are developed at research labs, and I think a lot of great data is there, and also using free and open source frameworks. We need really a platform to exchange those, and to exchange those within the community of Earth observation experts, but also link in the local level where you have really the users and understand really how can we make data fit for purpose. How can we also make algorithms available to fit local data needs? And I think this initiative we are starting is a local cities and municipalities to understand what is actually the opportunity of such data.
Great, Monika. Thank you very much.
But we typically share image data.
Okay. Yes, there was a little bit of a technical issue there at the end, but I think your message was well heard. Thank you. Marc, over to you for the next set of questions.
Thanks, Argy. Yeah, we have a questions actually to Dilek now. During your presentation, you demonstrated that there is a great potential to complement Earth observation data with citizen science data for better monitoring the SDG 11, and you give a very good example on SDG 11.7.1 on open public space. In your opinion, how do you think how can the Earth Observation Toolkit for Sustainable Cities and Communities that we are developing together can help cities embracing this crowdsourcing approach if they don't have any experience with it, which is, I think, the case for many countries and cities?
Thank you, Marc, for the question. Well, crowdsourcing or citizen science more generically has the potential to complement Earth observation approaches by providing local perspectives through ground knowledge and interaction with the local communities and stakeholders. Therefore, it could produce up-to-date, accurate, and timely data considering the local context, which is very important. And this is complementary to Earth observation data. Therefore, we plan to include relevant citizen science data sets, tools such as the ones I mentioned in my presentation, and also successful examples to this toolkit. If we look at the current landscape of citizen science, we would see that many of these initiatives are at the local and community levels. They are more bottom-up because of that, and this is very relevant to cities. And most cities are already very well aware of that and want to work towards involving citizens and communities more actively in decision-making processes. But they need to know how and where to start to realize this untapped potential of citizen science, both as a source of data, but also as a means to address the societal challenges they face. So that's why our toolkit will also promote citizen science approaches to complement Earth observations data. And we expect cities, because of that, to embrace these approaches along with Earth observation data. Thank you.
Thanks a lot, Dilek. Actually, I will ask the last questions to Samira, because Samira, you represent a bit the end-user communities, if I can call you like this. You highlighted during your presentation the need for countries to test and adapt Earth observation methods and tools to their local specificities, that means to the national and city context. Can you give us some examples of the evaluation criteria that you've been using to test the usability of Earth observation products and tools in a local context?
Thank you, Marc. In fact, in our case, we have used Earth observation methods and tools as part of the pilot project on only 2 cities, at least Tozeur and Monastir. The results of the study obtained were satisfactory for most of the representatives of the various administrations in the 2 pilot cities under study. The people are mostly connoisseurs of the context of their cities. It is true that this kind of tools based on the observation of the Earth aren't commonly used for them. On the contrary, it is a new technology, but that doesn't prevent that the results presented aroused interest and rigorous evaluation of their part. For example, the representative of the 2 cities were very satisfied of the results concerning the boundaries of the 2 cities. They all know that the administrative boundaries don't coincide with the real boundaries of the city. And the fact that they used the definition based on the built-up extent, it was appreciated because they already know that the city has grown, of course, but the people that have built housing outside the city are still being considered as part of the population. So, in my opinion, I think that the most important criteria for evaluating the quality of Earth observation tools is, in the first instance, the appreciation of decision makers and connoisseurs of the of the area itself. So, thank you.
Yeah, thanks, Samira. Maybe just a very quick questions on the toolkits that we are developing together with UN Habitat. How would such a knowledge sharing resource support your activities in applying Earth observation for urban sustainability?
The availability of expert Earth observation resources, adequate tools, and good practices can greatly assist in monitoring the urban sustainability of cities. For example, for our case, we didn't use the toolbox, but I think that to complete tool that simplifies the task of technicians and lightens their workload can only be beneficial. The fact that the toolbox makes it possible to bring together all the means and tools necessary for monitoring urban sustainability may, in my opinion, encourage governments, agencies, cities, and technicians to start the work of calculating urban indicators for all the cities of the country and at regular intervals. This is my opinion. Thank you.
Thanks a lot, Samira. Over to you, Hardy, to conclude the session.
Wonderful. Great. Thank you very much to all of you and for participating in this panel, also for your very informative presentations. I want to thank, in addition, Robert Ndugwa from UN Habitat and Stephen Ramage from the Group on Earth Observations for helping organize the session, and Robert for your introductory remarks as well. Thank you also to you, Marc, for your great efforts to making this session possible. Of course, we also want to thank all of you for listening, and like everybody in this forum, we would have preferred to meet you in person in Bern, but given the current pandemic, we were not able to do that, but we're very happy that we were able to convene virtually and share some of these experiences and messages. We would like to encourage the audience to share your questions and reach out to the meeting organizers, moderators, as well as the panelists. A lot of the connecting details are included in the presentations and will also be provided through the UN World Data Forum webpage. So please do reach out with additional questions if you would like to know how you can get involved and become part of some of these efforts and initiatives that you've heard about. Please let us know and we would be delighted to converse with you. So with that, thank you very much, everyone, and we will conclude our session for today. Thank you.